Okay, so if we have so if we have so 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 if that's our if that's our question, right? And then you're asked to say find the derivative, how do you go about it? So first things first, we want to discuss the principles like we've always done. It's always easier when the principles are there, because then you don't only have to memorize this, but then once you've gotten a hold of the principles, you can pretty much be able to use them. You can pretty much be able to use them in any situation, and that's what's more valuable, than just memorizing a set of questions. So really, we are going to talk about the principles here, but then we are going to also be able to bring in things such as the product rule, the quotient rule, the chain rule, all those rules that we talked about. That's why we actually had to start with them, because they form more or less like the foundation for for everything that we'll be doing. So the same way that we are using the product rule, the chain rule, the quotient rule, the same way that we are using them, for the general differentiations, for the trigonometric differentiations, pretty much the same as we are going to use them for these, exponential and logarithmic what functions. So when you have a question like this, first of all, you have to determine what your derivative is. Okay, so you have to determine what your derivative is. So for this, what you are going to do, you first want to that 2x, you want to make it as your as your u. So in coming up with our formula, so it is dy dx, so it's going to be, so we're going to have our u. Let's write it here. So our u is going to be 2x. Okay, then our formula is going to be e, then raised to the same u multiply derivative of u. Then if you want, you can then put ln e, but of course you know that ln e is basically going to be what, 1, because remember, ln in its own right is what, it's log base e. So if you put just ln on itself, but when you put ln e, it's what, it's that. And we know that for a log, if these two are the base and that are the same, you're basically having 1, isn't it? So that's why you see that for most of our questions, we even be able to just leave the ln out, but that's just so that we can be able to know what's happening there, right? So now for this question, I want to find our derivative of u. So we know derivative of u from what we've been discussing from the past topics, from the past subtopics. It's going to be simply 2, isn't it? So now what we are going to do, then we are going to say e, then we are going to say that's going to be, okay, let's just substitute everything. So 2x, we've substituted the u, times 2, and of course times, if you want ln, but of course, like I've said, the ln e, it's still going to be what, this is going to be 0. So you're writing it, you have something like that, you have something like that. Of course, it just looks neater when you write your 2 in front, isn't it? So basically, that's really what you need to know about these things. But then we'll then be able to talk about other things. But before we can talk about that, do you have any questions from what we've talked about just now? Okay, any questions? Okay, so if there are no questions, then we are going to then look at this thing which I feel is very very important. So if you've got ex and then you've got e to power x, then you are told to differentiate these. How are you going to differentiate? So this is y. Okay, pardon me. So if you've got that, so that's y, then you've got that and that. So now how do you differentiate this? So for the first one, you've got e and that. Now remember, e is a number. Okay, e is a number, e is a number, e is a constant. That's why if you've got e and then you're told to find the derivative of this, you know what the answer is? It's 0, because e is a constant, e is a number. So meaning that what you're looking at here when you have a question like this, it's the same as though you just have 2x, the same as though you've got 3x, just as basically the thing. If you say we've got 10x, because you are taking e as just any number, it's a number, it's a figure, it's a constant, right? So then if it's a constant, meaning that your derivative is going to be what? It's going to be e. Then for the second part, for the second question rather, what we are having is e to power that. So then what do we do? Remember what we said? So what we are going to do is, so remember what we do? So what we are going to do is, we are going to say dy dx. So we are going to say e raised to u. First we've already so defining our u to be x, we're going to say u, then derivative of u. Of course we can put ln e, but it's still one, all the same. So you're going to put e. Oh, let's find our derivative of u. It's going to be 1, isn't it? So substituting there, times 1 gives us what? E to power x. So that's why this they call it a special derivative, because this is one where y is equal to the what? Is equal to the derivative. So this is what some things which we call as the special ones, isn't it? The special function, right? Where the where the y is equal to the derivative. So that's something. So that's something that you have to take note of. Huh? Then let's talk about this. Then okay, so let's talk about let's just have a refresher on the power rule, but this is just going to lead us to talk about how you deal with such a question. Okay, so the reason why I'm bringing all these things is because these are the little things that tend to you know to throw people off. So that's why I want us first to discuss all these things, so that even when we go to the other things, everyone is going to be relatively comfortable with what we are doing. And so without foundation set, I think no one should be able to should have challenges. Huh? So then, pardon me. So you have, so using the power rule, we are going to have what? We are going to have, so meaning for that one, we're going to have 3, then you're going to have x, then, sorry, pardon me, it should be 1. So So that's that, right? So meaning for this one, nothing is different. Remember, E is a constant. E is a constant, right? So if you always picture it that way, you won't have challenges, right? So just picture it what for what E is. E is a constant. So if it's a constant, we will treat it the same way we treated the N. Because E is a value, which of course you can't evaluate without a calculator. So you just pretty much leave it in that shape. Okay. Now let's see now what we can be able to do for let's now see if we can look at other questions just so that we can be able to appreciate some concepts. So then what happens if you have so all these are just to help us build up the concepts, okay, before we can do the actual things. So can someone tell me what would be the can someone tell me what would be the derivative of this, okay, and what would be the derivative of the second one, this? Okay, so anyone just to speak up and just give us the answer. Anyone? Okay, so the first things first is your formula. So you're going to say it's EU times U.
Yeah, I think the first one will be 0.
Yes, exactly. Great. So it's going to be 0, right? Thank you. Thank you so much. So yeah, it's going to be 0, right? So it's going to be 0. Then, so that's going to be 0. Now, we know that, yeah. So now let's see how our good friend arrived at that wonderful answer. So what is our U? Our U is 2. That's why I went through all those steps so we could understand this. So meaning U prime is what is 0. So meaning we have got the E to power 2 times what times 0. So that's why it's 0. So these are concepts that appear to be very easy, but it can be so easy to focus on the big things that you lose track of the fundamentals. So that's what's important to take note of. Huh? Now let's now answer the second one. So the second one is going to be again the same thing, u times u prime. So you have to define what's your u. So your u is what? Your u is x squared. Remember, using the power rule, you're going to have 2x, isn't it? For your u prime. Then what you're going to say, you're going to say u times u prime, which is going to be e, that's going to be squared, right? Times the prime, the u prime. So meaning our answer is going to be 2x and e x squared. So yeah, that's pretty much about it, right? Easy, huh? So these are the fundamentals. Of course, we are for now we are dealing with this, but we'll also be able to talk about other things. But for the exponential, this is it. This is what you need. These are the fundamentals that you, these are the fundamental principles that you need. The rest of the questions that we'll be looking at, they'll just be more or less application of everything else that we've done, right? Everything else that we've done, we're just going to combine everything and then boom, we are going to have our answers. But so once you've gotten to understand what we've just done now, in the past 21 minutes, then you've got to be in good shape, right? You've got to be in good shape. So let's now see how we can apply these in questions now, because all these were just building principles. So you have that, then you've got sine x, right? So now what you're going to look at is the same things, right? So you see now you have to be able to have all the knowledge readily available to you so that you can be able to use it. So now here again comes back to the what, to the trigonometric what, to the trigonometric differentiations, right? So what's our u? So we know that our u, oh, sorry, not the u prime, just u. So we know that our u is what? Our u is sine x. So what's our u prime? Our u prime is cos x. That's great, huh? Then we now say what's our dy dx. So our dy dx is going to be eu e to power u times what? Times u prime. Of course, it can be ln e, but it's going to be 1. So doesn't serve any purpose like we've discussed earlier on. So there now we're going to say e, then your u, what's your u? Your u is sine x multiply what? Multiply cos x. Okay, so that's about it. So if you want, you can maybe want it to look like that, whichever you prefer anyway. But yeah, but the point to take home is that this is your answer. So the point is that it's all about the principles. Okay, once you've gotten your principles right, that goes on well. So let's try others. So the question that we have upon us is that, so we also look at the how you can have questions to do with the product rule and all those things, right? So now how do you go about it? Again, the principles that we talked about. So what's your u? Your u is going to be your cos 2x. Then what's your u prime? Now remember, differentiating something that is not just x. Remember that we have to go a step further, isn't it? So what you do is you get your u and say it's going to be cos u times what? Oh, sorry, not really cos u, but anyway, you have to find the derivative of what? Of the cos. So you have to find the derivative of the cos. Then that derivative of the cos. So you know derivative of the cos is what? Is negative. Remember, anything that starts with a c, its derivative is negative, right? That's what we discussed. Huh? Then now let me use different things so we don't lose track here, right? So remember, this is our u. This, the u that I've written there, that's the u for the question that we are trying to answer. Now we know that we found ourselves in another unique position where for us to find u prime for this question that we are having, we have to find this. But again, to find this one, we have to have our mini u again, right? I'm calling it mini u so that we don't really confuse it with the what? We don't confuse it with what we are really trying to solve for. So I'm okay. Let me just use this side, right? But you'd have to show your working. But I'm just writing it this side so that people just don't, so that we don't make mistakes, right? So you take this as that, but of course you may have to write it as your u, and then you would have 2x like that. So to find the u prime, you then have to say, remember, the derivative. You know, anything that starts with a c, the derivative is a negative, starts with a negative, isn't it? So cos 2x, we're just going to say minus sine u times what? Times the derivative of u. Now, the u that we're talking about, that's what I've separated, right? The u that we're talking about here is what? Is 2x. Please don't get mixed it up. Don't get it mixed up. So that's why I've even chosen to do it what? To do it separately so that we don't make mistakes, right? So then what we are going to do is minus sine 2x times what? So now you want now to ask yourself, for this u prime that I'm having, the 2x, what will be the derivative? It's going to be 2, isn't it? So then you're going to say multiply 2. So meaning, of course, meaning now what we're going to have is negative 2 sine 2x. So yeah, so that's basically what your answer is. Now remember, this is the what? This is the u prime for what? For this one here, the one that I'm now writing. So please don't get that mixed up. Huh? Okay, so are we on the same page this far? Okay, so having done that, then we know that here it's just a direct run, right? So we say it's going to be u times u prime. Then we are going to say uh, so we are going to say this is cosine 2x, then times negative 2 sine 2x. Okay, so that's about it, huh? So um so that's how I would answer that one, right? So that's how I would answer that one. So the one that takes screenshots, you've already taken before I can wrap.
Yes, thank you.
Okay. Okay. So now remember what we discussed earlier on, right? I said if you've got let's say e raised to power u, find the derivative, right? So let me write it properly. Okay, so if you've got something like that, then dy dx is going to be how do we go about it? So we're going to say that, and then u prime multiply by ln e. Now the question that I want to, okay, let me put this as u, so that's what we can talk in general, right? So now what really is important, you I want us rather to discuss something, to say where is the ln e coming from. Remember, ln in its own right is what? Is log to base e, right? Yeah, but if we put an e, so the e is coming from what? Is coming from this. That's why the ln e is coming, because remember, ln in its own right is what? It's log to base e. But when you put an e, then it becomes ln e, isn't it? That's where it becomes 1. But now, so if we then have a question that's different, and that is like, let's say you've got something like 2x, you've got something like 2x. So how do you go about it? Okay, how do you go about it? So maybe before we can talk about this, let's use a generalized thing, right? Like let's work with something that's going to be generalized. So let's work with au. So it simply means that for me to find my derivative for something that's any other than that's other than base e, I'm going to say au times u prime times ln A, right? So that's basically what you are saying. So now, because that ln A, it will only be 1, ln e will only be 1 if that a is what? That a is e, okay? So it means simply means that if we are trying to figure out an answer to a question such as, let me just raise this up. So if you're trying to figure out an answer to something like y to power x, so you're trying to figure out an answer to something like this, then what you would have to do is you're going to say 2, so you're going to say 2 and then u, so you have to devise what your u is. So u is simply x, then u prime is 1, isn't it? So it simply means that's 2 power u, then u derivative, that's 1, then times ln. Now what's this ln going to be? So this ln is going to be equal to what? To 2, isn't it? So then you're going to have to say, let me replace now the x there for the u, and then the ln 2, since that one is just 1, so I just multiplied. So basically that's how you would answer such a question, right? Okay, so is everyone clear up to this point? Okay, so let's see how we do it. So now let's now look at this question. Okay.
So, sir,
Yes.
like, yeah, for the same, the previous one that we are just from doing, if we were to write it in the log form, it will still be considered to be right.
That you write log base e to 2.
Yes.
Yeah, that would be right, but again, that would be, what's this, it's better if you just use the one in form of ln, because yeah, because I think that's more or less like the standard. So even the one for the log e, it would still mean the same thing, but again, it's that thing that you always prefer to go with the standardized form, isn't it?
All right, sir.
Yeah, so yeah, but it basically just means the same, but again, the fact that there is a formula, it means that you know you would be expected to use the formula, because sometimes you may say, maybe perhaps this person just forgot the formula, then they just wanted to salvage themselves, so things like that. So if there's a formula, if there's a standardized way of doing something, go with that standard method, go with the standard method. Yeah, so that's about it. So now let's see how we're going to answer this one. So again, it's basically the same thing, right? So that's why when you practice these things so much, it reaches at a point where you just look at a question and then you just start smiling in the exam, because you know that you're going to get it right. So but trust me, differentiations, these are where marks should just be flowing, because you're just repeating the same stuff, you're just repeating the same things. So this should be free marks, like free marks. So there you have that. Yeah, because I'm sure some of you are like, we're doing the same stuff. Okay, so what's our a? Our a is 4 in this case, right? So we are going to say 4u. Let's write our u. So our u is what? Our u is x squared. Then our u prime is 2x. So our u prime is 2x, right? So you write that 2x. Then ln what? Ln 4. Yeah. So after you've done that, then you want now to you write this in terms of so 4x squared times 2x. Okay, I'm going to remove all this. I'm just want to write it full so that we can all follow. So I'm going to say, how can this be made neat? Okay, so I'm going to say 2x 4x squared and ln 4. So basically that's how you would go about it. So you see, it's basically the same thing, just you doing the what, the same thing. So let's just look at the next example before we can look at a different concept, huh? So let's just do another example before we can look at a different concept. I'm sure with this one everyone should be comfortable at this point. So again, remember, it's just repetition, right? It's just repetition, just repetition, same thing, just repetition. Okay, so we've got it, right? So there now, we just begin now to just plug in things. So you'd say times u prime, that's going to be 4. Let me just put brackets so we don't miss them. Times what? 10 ln 7. Okay, so what you're having is, okay, let's just write that. Yeah, you would write it like this if you wanted. But yeah, but the take home message is how you do the differentiation. So, are there any questions up to this point? Okay. So now let's now go a step further and see what we would like to talk about. So we've talked about the exponential. Now let's talk about the,
Plus,
yes.
concerning about the same example, like someone be attempted to use the chain rule. Can it work?
If you attempt to use the chain rule,
Yes.
yes, you can explain how to use the chain rule.
I just wanted to find out because looking at it, seem like the same question that we are doing for chain rule to apply. Now I just want to find out if it can work.
So remember those the questions that we started with. That's why we went through those questions to say if you have something like that and you have something uh, like that, these are entirely different things. So that's why the earlier questions that we discussed, that was the reason why I was going through those questions before we started to look at all these things, because it's good to differentiate them. So those two things that I've written are not the same. The first one, yes, quite alright. You could use the chain rule. That's a straightforward. You could use a chain rule for the first one. But for the second one, pretty much you can, but I would always encourage you to always go for the standard. Yeah, to always go for the standard, because not only does it lessen the workload, but you also reduce the risk of making errors, huh? Like you also reduce the risk of making errors. So whereas maybe that can work, that may not work, but what I would always suggest is to always go with the what, to always go with the standardized methods. Yeah, so that's pretty much about it. So if it can work, if it but always go with the standardized methods, because something can work, but if it's not standard, some lecturers may not buy it. And so you'd end up losing marks because to them, they might think like you've just done some MacGyver work. Like, yeah, and not really followed the principles. So that's why it's very, very important to always go. And that's why I was giving us those patterns, right? The patterns of questions. Yeah, so that's why I started with those patterns of questions so that you can be able to know what principles you are expected to use for each pattern. That way, you are sure that you won't lose any marks in your calculations, right? Because you'll be able to include everything for what those particular principles entail that you use. So that's the important thing to take note of. So now we can now talk about the
All right, sir.
okay, okay, sure, thank. Okay, so now let's now talk about how it differs. So we've talked about the exponential functions, and so we'll be able to look at things, of course, such as how to use the product rule, how to use the quotient rule. But let's just go to the logs, to the logarithmic differentiations, and then of course, then we can now just start playing around with all these all these other questions, right? But I feel once we discuss this, I think these are the fundamentals. The other things will just be pretty much a build up on this. So that's about it on the exponential. So now let's now talk about, so that's the question at hand. You want to differentiate that. What how do you go about it? So first things first, you want to say of course dy dx. Then you are going to write this as ln u. So you want to write this as ln u. Then what then you're going to do is you're going to get the derivative of u, make it the numerator, and then the original one, make it the denominator. That makes sense? So you get the u. So like for this particular question, so like for this question, what is our u? So we get our u for this question. Our u is what? Our u is going to be x, isn't it? Then what's our u prime? Our u prime is 1. So let's now plug into our equation. So it's going to be dy dx. Then we are going to have what? 1 over x. So that's how you differentiate this question that I'm putting a star. Okay, pardon me. Okay, yeah. Okay, yeah. So that's how you answer that question there, right? So that's how you would want to go about that question. So yeah, so that's how you'd want to go about that question. So now let's now look at another question just to be able to ensure that everyone is comfortable with this concept. So you've got a question like that. How do you go about it? So first, always define your u. Okay, always once you take a systematic approach, you won't really struggle with, no, I forgot to add this, I forgot to do this, because you'll be taking what a systematic approach. So once you do that, then you say, oh, okay, so meaning my it's going to be u prime is 2x, then x times x. So it's going to be, I cancel that x, I cancel that x. So you are going to have what? 2 over x. So therefore, so um now, like well, like the question that we are just being asked a short while ago, where someone was asking if you could leave it in logs and everything. Well, remember that. Okay, so let's look at this question, but not necessarily that I'm saying that you leave it in logs, but I just want to show that really the concepts of logs still apply. So remember, this is the same as this, right? This is the same as x squared, right? So meaning that you can rewrite this as what? Remember, you can bring this there, right? So you can have log 2, isn't it? Ex, huh? So meaning this is the same as what? Ln what? Ln x. Then you know that the derivative of ln x is going to be, so it's just 2 times. Remember, it's going to be u prime. Remember, u is what? U is x. Then u prime is 1. So u prime is going to be 1 over what? Over x. So you see that the value, the answer we are getting is still the same, right? For the derivative. So that's another way you could want to think about it. But anyways, I just thought that would be a good thing to take note of. Huh? So then let's see if we can be able to do some another example, just to be able to take that point home. So
So have you cleared the previous page? I didn't screenshot.
oh, I've cleared this. I've cleared. So you can be letting me know. Yeah, you can be letting me know. So I don't clear it. Okay. Okay. Now, so that's the question again. So how do you go about it? Remember, always define your u. Okay. So let's define our u. So our u is what? Our u is x squared plus 1. Then what's our u prime? Our u prime is going to be 2x. That one becomes a 0, isn't it? So we don't really get to think about it. So then we are going to say, remember, dy dx is equal to u prime over u. So what we are going to have is 2x over x squared plus 1. So that's how you want to go about these questions. So now, okay, so now let's now see how we can be able to go about something like this. So again, define your u. So u prime, remember it's starting with a c, so meaning its derivative is going to have a negative, isn't it? So then you're going to say dy dx is going to be u prime over u. So it's going to be negative sine x over cos x. Of course, you know identities, that becomes tan x. Okay, so that's how you'd want to go about such questions. So now we've looked at these questions. Let's see how we can go just a step further. So if you have a question like this, so if you have if you have okay, then you are told to differentiate that. So how do you go about differentiating that. So what's important is, again, the fundamentals, okay? So it's going to be very similar with the one for lean, for the natural log equation, yeah? They are going to be similar, but we're just going to pick out the key things which are going to be very helpful. So how are we doing it for the lean E? So you know that for the lean EU, what are we doing? We are saying U prime over U, isn't it? Now remember, like I've been saying, this lean E is the same as what? It's the same as log E, and then with a U there. And then you're getting what? U over U. But the fact of the matter is that actually, you're actually having a what? You're actually having a log. You're actually having a log E, okay? So you're actually having log E. Okay, so why am I having the log E? Because remember, the natural log in its own day. Okay, let's do it like this. So let's write it better off like that. So the natural log, you're actually having the natural log, right? So you're multiplying it by that, the lean E, isn't it? So the E being what? Being the natural log, okay? Now, so we know that lean E is equals to 1. So meaning basically here, we're actually taking note of the what? Taking note of the log. It's just that it was lean, so it was lean E. So that's why we are not. So that's why we're just having it as that, as U prime over U. But when we have something that's not a natural log, what we are going to do is we're going to have that, and then we're going to have U. So it's going to be basically everything the same, but this time around the denominator is going to have lean. But remember, it's not going to be lean E, it's going to be lean A. So that's basically how we are going to find our derivative for our wonderful question here. Okay, so that's how we are going to answer. So before we can before we can be able to proceed, I hope everyone has gotten that concept. So remember, there's nothing to memorize here. I think everything is pretty much adding up. So that's the key thing. Remember, you don't want to memorize. You don't want to memorize. It's better that when you know, because that way you can easily recall it to memory, isn't it? So that's one thing that you want to do. So let's now go to our question now. So our question was that. So it was okay. So 2x there, right? Now we know we have to define u. So what's our u? U is 2x. What's u prime? U prime is 2. So then you're going to have dy dx, which is u prime times over u times ln a. So what's your a there? Your a, remember where the ln was having an e, you are having a 3 there, isn't it? Yeah, you've seen that, right? So I'm just going to plug in all the values that we have. Just basically, so you're going to say ln 3. So you cancel that, you are remaining with 1. So meaning you're going to have an answer that's going to be 1 over, the 1 is over everything, okay? Okay, let's just write it properly. Yeah, so the 1 is over everything, and then you write it like that. So basically that's how you would differentiate. So it's just about the principles. Once you get the principles right, you won't have any challenges. So let's look at another example before we can be able to proceed to the other things. Okay, so it's this again. You do the same thing, define your u. So you have your a is 5. So dy dx, that's going to be u prime over u times ln a. So you just have to plug in the values, x squared times ln 5. So you cancel one x, isn't it? So one x is cancelled, you remain with 1, then that cancels. So we're going to have what? 2 over x ln 5. So that's what you are going to have. So basically, that's how you'd want to go about this question. So yeah, so we said that we'll go through. Okay, I think let's just do this last one and then we'll be able to look at okay, so let's just do this one rapidly and then I'll leave us with one where we can be able to start from next time, right? So we're going to have, okay, so in the remaining time, let's answer this one. Okay, so we are having, so your u is 1 minus x. Okay, so your u is, so your u is 1 minus x. So that's our u, not our u prime. Then our u prime, so our u prime is going to be what? Negative 1. Then our a is 7. So then we are going to say dy dx. Okay, so dy dx is what? Is u prime over u times NLA. Okay, so u prime is going to be negative 1 over u, then we have ln 7. So we have ln 7. Now, when you look at the way this one is, there's basically no way you can be able to break this down into make it a simpler thing, isn't it? It's just really what it is. So that's about it. So yeah, so that's where we'll end for today. So when we continue, we'll look at now how we can use the product rule and the quotient rule as we combine the concepts that we've learned uh, today, and then we'll just be able to put everything